Hello there. So we are reviewing Kalman Filter in its simplest form for one variable using Python. This is accomplished in less than 10 lines. These highlighted lines implement Kalman Filter for one variable. If you look at the actual papers, they make it look more daunting than it is. So we are going to demystify Kalman Filter today. So let's get started. Let's also fix some notation. So Kalman Filter is a process that helps you estimate dynamics of a system when there is noise in the system itself, and also there are measurement errors. So if you were to follow this diagram, which is coming from a paper from 2006, an introduction to Kalman filter, there are numerous papers, but I'm choosing this one as it seems to be popular. So on page 6 you see this diagram. So what is process noise is represented by Q in this notation. Measurement uh, noise is represented by R in this diagram. We call it sigma measurement and sigma process. Further, we generate some data that we will try to estimate, and then we introduce some noise based on measurement sigma into that. Then we initialize some of the variables, which is not very important. Let's go right into the Kalman filter. So the first equation on line 27 is referring to the first equation over here. The difference is we have one variable only and we do not have this b and u terms. They are assumed to be zero for simplicity. The second part is the prediction covariance update or prediction error update in our case. This is just the estimated error from last period plus the error in the sigma process. So these two are done. And then we go to the update or update the measurements. We have something called Kalman gain, which is essentially the weight. And I'll let you know how I think it's a weight. So there's a prediction error that we got from here divided by prediction error plus measurement error or the noise. So this thing is always going to be less than one. So and they call it Kalman gain instead of a weight. Line 32 is the same line as line number 2 in the diagram. However, I feel it's a little bit more intuitive if you rewrite the same thing a little bit differently. So so we are saying Kalman gain or the weight on the measurement is one thing. So we give Kalman gain as the weight to the measurement and 1 minus that to the predicted stock price. Predicted stock price is the prediction from last time period, right? So it's just a estimate is just a weighted average of prediction and measurement. And Kalman gain is the weight on measurement. 1 minus Kalman gain is the weight on prediction. And the last line is we need to update our error. So see, we had used 1 minus Kalman gain as the weight for prediction. We are going to use the same thing, 1 minus Kalman gain as the weight on prediction error, and get our this period estimated error. We run this in a loop, and what we get is this diagram. So in this diagram, the blue line is a true variable, true stock price in our case. Green line is the estimated, and orange line is the measured with noise. So you would see blue and green line are somewhat closer compared to orange line. And therefore, we gained substantially by employing Kalman filter. I hope it was helpful. Thank you so much for your attention.